Hello and good day, and a very warm welcome on behalf of NTI Audio. The XL3 acoustic analyzer is a professional device focusing on three main applications and markets. First of all, the sound level measurements. Then we have the room acoustics, particularly talking about reverberation time measurements. And third one would be the building acoustics with sound insulation measurements. In this webinar, however, we will solely focus on the sound level measurements. My name is Markus Becker. I'm presenting this webinar and I'm assisted today by Greg Schmiedle, our product manager. He is mainly taking care of the incoming questions and comments. To the left, you see the topics that we have prepared for you. We will start with an overview on the typical applications of sound level measurements, and then we will already dive into the practical presentation by showing you the features and the operation of the numerical display, of the level time history, the spectrum. We will introduce you into measurement series, as well as presenting the data transfer and verification from the device to a PC and so on. After that, we will summarize the key topics that we have presented and add some more hints. I expect that this presentation will last about half an hour. So let's talk about typical applications of sound level meter measurements. First of all, we have the sound analysis. Be it in a machinery hall, be it in an open space office or in free field, whatever. Here you are interested in measuring the broadband level to identifying possibly and analyzing the spectrum of a specific sound, maybe to determine the noise exposure level in a workspace. So these are the typical applications of sound analysis. Then in a second field, we have the live sound surveillance. Depending on the country where you are, you need to monitor specific levels like the LAQ typically, maybe the LC peak or a gliding LEQ or other values. Then you have to apply a level correction because the place where you are mounting your microphone will be hardly the loudest place in the audience where it basically should be. So you have to compensate for that difference, or you have to apply certain limits, thresholds, and if they are exceeded, you need to take actions. So the test instrument in this case should assist you in doing that. And last but not least, we have the long-term noise monitoring. So here you are recording level data, spectrum data, or even audio files over a long period of time. You want to identify the statistics of the sound levels that have occurred during that monitoring period, percentiles. And here, of course, especially the connectivity of the device, of the measuring device to your PC, to your office plays a major role. Maybe you want to remote control the device. Maybe you want to access the data that have been stored on the device. So that is a key aspect of noise monitoring. That brings us already to our practical presentation. I have here on my desk an XL3 sound level meter with the M2340 microphone. You see it here in the webcam. By the way, this device is connected only by Wi-Fi to my system, so there is no wired connection actually. And I'm using the connect.ntiaudio.com website, which is a service that we provide for all XL3 customers. You're going to see that in a minute. Furthermore, I have an Emma Pro on my desk with a talkbox in order to create some test signals in order to illustrate the measurements I want to show you. So let me flip over to this website, the NTI Connect. I'm refreshing the website. I have already connected it to my device. And there is, of course, a minor time delay due to the video transfer from the XL3 on my desk to the screen, what you see here on the website. But basically, you have a real-time access to the measured values as well as a remote access, a remote control to the instrument. So I can push the buttons on my device, or I can do that here with my cursor on the screen. It's the same effect. I can fully remote control device through these buttons. So let us start by pressing here on this icon and entering the configurations. This is generally advisable before you start a measurement. Take a brief look at the configuration, because here you are adjusting some fundamental settings that may have, of course, a major impact on the data recording, on the results you are storing on the device during your measurement. So let's start with the top entry, report and logging. Here you can select whether you want to record spectra, be it just the LEQ or selection LEQ max min or all spectras. So I leave it here with all. We can adjust the logging interval to 1 second or maybe even 100 milliseconds, what I'm doing right now. We can activate the audio file recording with different formats and sampling frequencies. In my case, I'm going to switch it off because it's not necessary, but you can simultaneously with your level measurements record the audio. So that will allow you to listen to what has happened after the measurement has been completed. This is a feature where you can create a new file with all the recorded data every 24 hours. So in order to avoid a huge file, you can split that into 24 hours chunks, and you can decide here on that list which date, at which time you want to start with the creation of the next file. Here that is the selection for midnight, but you could choose any other time by that list. And last but not least, you can decide whether the instrument shall log all the measurement data, all the levels, which means all the thinkable combinations between A-weighted or frequency-weighted, time-weighted, percentiles, K-fact, correction factors, whatever you can imagine, all means all these combinations will be stored. Whereas when you go to select, you have a list of a couple of levels. You can add more, you can edit that. So this is my selection right now, which I prepared, but yeah, that depends on your application. I leave it with all because then I'm on the safe side. I will not miss anything. Okay, next entry here is the gliding LEQ. This means that you are recording the gliding LEQ over a certain period of time or several periods. The ones you see here are the default values. You can amend them if you like. You have a choice. So from seconds to minutes, whatever you want. I leave it as it is. I just wanted to show you. Same with the level statistics, the percentiles. You can edit these values if you need other percentiles. You can also decide whether you want to have a different frequency or time weighting. Again, I leave it, but you see we have a lot of possibilities and choices here. Then coming to the correction value, this is a typical live sound application. You remember, if you are a front of house guy and you have to monitor the sound level in the audience during a concert, you must make sure that it's not exceeding a certain level. And in order to determine that, you should measure the sound level at the loudest point in the audience, but this is hardly possible because there the people are standing around. So what you typically do is you place, before the concert starts, you place the microphone at this loudest point, you replay a reference sound, for instance, a pink noise, and I'm going to do that right now, just for a demonstration purpose. And I click on start. So over a period of 5 seconds, which is again selectable down here, I have recorded the LAQ and the LC peak here at this position, which is virtually my loudest point in the audience. And now I would move my microphone to a different location, the one where I'm actually measuring during the concert. And I repeat the same procedure. So I switch on again my pink noise and I start the 5-second measurement. And you see the result. Here was the loudest point. That is the actual measurement point. That is the difference, the K1 and the K2. They will be saved on the instruments, and you can recall them or you can apply them whenever you want during the measurement. Next would be the display layout. Very simple. You can select whether you want to show a large result and 2 small ones, or 5 small ones in parallel, or just 1 large one. I leave it the way it is here right now for the sake of simplicity. And I'm coming back to the measurement series at a later time of this presentation. But let us go back now to the numerical display. And here you have the choice to select which values you want to see. By the way, as I said, I can click here with my cursor. I could do that with my finger. If you look at the webcam, I can tap on here, and now I'm entering this pop-up menu, and that allows me to change the frequency weighting, the time weighting, live maximum, takt max. You can apply the correction that I just recorded or not. So you're really free to adjust the level, the display, to whatever you want to see. Wait a second, I'm going to show you one more, because here we have even an extended menu. We can select, for instance, percentiles, see the correction factors. You could even choose this entry, which means nothing will be displayed. If you want to avoid that anybody sees what's going on, maybe this is an option, maybe this is requested by you, or you can again click on more, and then you would see these differences. So these are predefined level differences according to national standards. Depending on the country where you are, you can select any of these differences to be displayed on the device. But I renounce on doing that right now. But I want to show you is the limit setting. Again, I click here on that entry, and now I go to limit. I activate the limit, and you see here I have 100 dB for the red alert and 90 for the amber, but I'm going to amend them. So I'm going to delete these values and replace them by 80 and 60 dB. I confirm, and you see the impact immediately. As soon as I'm talking louder than 60 dB, the display will turn amber, so giving you a certain alert. We are coming close to the limit. And if I'm getting even louder, then the display turns red, and that tells you, hey, you have to take action. You have definitely exceeded the threshold, so you have to turn down the volume. Last but not least, here to the left bottom corner, you see the timer, which means you can decide whether the instrument shall just continuously measure. As soon as you hit the start button, it will start to the point where you hit the stop button. But you could also say, no, I know already the duration of my measurement. Let's say I want to measure for 3 hours. You can amend that. You can edit that from 1 second to 24 hours. So you can adjust the duration of the measurement to your demands. This would be a single shot measurement. So you hit the start button, and in this case, after 5 minutes, the instrument will automatically stop the measurement. Or you go for the repeated option. Repeated means that here, for instance, we are measuring for 30 minutes. Then the system will close the running measurement and immediately restart a new one for the next 30 minutes, and so on and so forth. And again, you can decide the duration of this repeated measurement. But I stick to the continuous, so I leave it as it is. Next screen is the level time history. And just to let you know, if you look at the webcam, by just moving with the fingertip on the touch screen, you are already in the next screen. And in order to show you what's going on here, I'm going to start the measurement. I click on start, and then you will see with a 100 milliseconds interval, the instrument is now measuring the level. The red curve is the LAS, the slow A-weighted, blue is the fast weighted, and you see the time history of the last 40 seconds approximately. And this gives me the chance to show you a nice effect to demonstrate the difference between slow and fast measurement, because I'm going to clap a mo in my hands. So you see the blue curve, I'm gonna just pause here. The blue curve was coming down much quicker than the red one. The slow weighting has a much higher inertia in order to smoothen, to slowing down the display in order to give you the chance to have a better readout, especially in case of very high fluctuations of the sound level. Well, maybe now you want to have a closer look on this effect, and now you could amend the scaling of my y-axis here. You see, I can zoom and scroll through the y-axis, but not only that, I can also click here on the x-axis, and then you will see in 3 stages a higher resolution. Here we have only 20 seconds. I can even go down to the last 7 seconds cyclically. So this is a very nice feature to have a closer look on what has just happened and to adjust the scaling accordingly. Of course, I'm going to stop my measurement now again. Of course, I can also just autosave. I can amend what I want to see. Instead of AS, I could, for instance, go to impulse weighted, or the other one, the blue curve, I could go to the EQ level. So here, as you see, I have a huge, again, the same huge amount of levels I can select of the one I need or the ones I need. Yeah, very, very nice and comfortable. Next would be the spectrum. Clicking on here, you see the 3rd octave spectrum of the current noise level. I can amend that from 1/3 to octave resolution. Just confirm, you see the difference. Now I have the octave bands, but I can also go back to the 3rd octave, and I can decide whether I want to have an automatic cursor mode or manual. What does that mean? I leave it with the automatic. I'm going to just show you that. Let's assume we have a nice sine wave. I'm going to activate that on my talk box, and then you're going to see the effect. So now you see the yellow line. The yellow line always follows the bar with the highest level. And by the way, you can also read out or see the readout of the cursor down here. Manual mode would mean that I am manually controlling where the cursor shall be, and I'm doing that via these arrow keys. So I can move the cursor to the right, for instance, by clicking here. I can even go to the very right-hand side. This is the broadband level, Z-weighted and A-weighted. They are permanently visible. And here on the left-hand side, you can decide, by the way, what levels do you want to see. You see we have these small yellow lines. These are the top levels, and you're going to see how to select them compared to the bars. So let's click on here. So we see have selected the Z-weighted with fast time weighting, and now for the top bars I have selected the hold. I could also go for the maximum, or here with the bars I have the live value. Just let you show what's the difference. Yeah, I needed to start a measurement to see the maximum. You see it right now. You see here, now the yellow small bars stay with the maximum that have occurred, and they will stay there. So this is up to me how I want to edit that. Of course, I cannot edit it during a measurement. I have to stop the measurement before, but now I could again get access to the settings of these displays. Same as with the XT graph, the level time graph. I can adjust the scaling. I can zoom and scroll through my spectrum in order to analyze a certain area with higher resolution, or the same here with the y-axis. So I can really decide what I want to see. It's very nice and comfortable. Now let's get to another very innovative and very nice feature, and that is the push service. We have now executed some measurements. So we have some data stored on our device. We can, of course, download them via USB, whatever, to your PC, but there is also a second option, and that is very comfortable. I briefly take a look here at the settings, and that means here I have connected my XL3 not only to the via Wi-Fi through the internet, but also to a cloud service, to a cloud drive. And that allows me to directly see what's going on in the device. Here, coming back to my display, to the recorded data, directly download them to my PC. So I'm going to show you that here. You see here, Nextcloud, that is my cloud service. And here you will see the files of the recorded data. So as soon as I start a measurement, I do that by pressing the button. I see a measurement is going on. You see it here, logging. And after a few seconds, I will stop it already. Now, if you watch here, there is a new icon, and that tells me the data are right now currently being uploaded, and you see them popping up here. So you see, after a few seconds, you have already the data that has been recorded on the instrument. You have them on your PC. This is really a fantastic feature to monitor what's going on your instrument. Next feature I want to show you, as promised in the beginning, was the measurement series. So I'm going to activate that here. I'm going back to my spectrum. And now, in order to better present that, I will activate with the bars, I will activate the LEQ. So now what I'm going to do, first of all, you see, after having activated the measurement series, we have a new button here, which tells me start series. I confirm. So I'm asked how to name this measurement series. This is the default value. I just confirm again. And you see here a counter that will tell me which cycle of my measurement series I'm in. So I will again activate my talk box, replay the sine wave, and start a first measurement. I stop and I confirm that the instrument shall save this data. Now I change my test signal just to show you the difference, what's going on, and I restart. That was pink noise. Again, I confirm. Now, for the sake of presentation, I will replay a third signal and also measure that for a couple of seconds. And confirm. Now here we have 3 cycles, 3 measurements. And by clicking on this one, you can now scroll through these measurements. You see look at the blue bars. These are the LEQ measurements of my last measurement, cycle 3. That would be the one of the pink noise, cycle 2. And that would be the one of the first cycle, the sine wave. So here you have a very nice feature that allows you to compare these single cycles against each other. And in addition, if you go beyond the 3, you will see the average. This is the average value of my 3 recorded values. And I will tell you in a minute what is the benefit of that, but this is a very nice feature that simplifies the acquisition of several measurements, let's say in a certain location, and saving them, of course, as isolated measurement in a combined folder, so that you have all the data at hand on one side. Now, for the moment, I'm gonna stop the series and just confirm. So let us take a look at the result files. All these data that we have saved, they will be saved in text format on the XL3. We can transfer that to your PC either with this cloud, with a push service I just showed to you, or via USB, whatever you want, or even here over via storage over the NTI Connect. You have direct access to the onboard memory of the XL3, but I'm gonna just flip over to some text files that I have recorded before. So these are the measurement results of some measurements. You see here the device information, the name of the device, serial number, and so on and so forth, whether there have been K values involved, whatever. And now you see with a timestamp all the measurement results for all these values, for all these levels. You see it's a hell number of values that have been recorded over time, and you can watch them. You can import them into Microsoft Excel, have a further analysis. You can use the Data Explorer, for instance, whatever you prefer. This would be a file, a report file. Report file means that's the summary, the overall result of your measurement recording. And here you see, in addition, there is a checksum, by the way, also in this file, but here it's the very end. It's pretty much down low. So every of these files has a checksum. And the checksum means that all the data that are here in this file, which are of course editable because it's just a text file, but they are calculated against the checksum. And by comparing the checksum with the content of the file, you can make sure that the file has not been manipulated, that none of these values have been afterwards edited manually. If somebody would do that, you will realize immediately, and I'm going to show you how to do that. But first of all, here again, another example of a Spectrum file. So here we have again the timestamps, and now we have for the different bands. It's not very nice to see it in a text format, but as soon as you import that into Excel, for instance, or into Data Explorer, you will immediately see the spectra over time. So let us take a look at this file validation. We have a software which is called File Validator that is available free of charge. I'm going to show you later how to get that. So what I have to do that, I run the software, I select the file I want to take a look at. Let's choose this one here. I confirm the instrument is checking the checksum against the content of the file. Green tick says, yes, it is valid. So there has been no manipulation of the file. You can really trust what is in this data. And last but not least, going back to our device. And now if I click here on this hamburger icon, you see these are the measurement modes that are supported by the XL3. We have the sound level meter, the one we have been looking at right now during this presentation. Reverberation time, sound insulation, they will be presented in more detail at a later time. But now here we have a fourth one, and that is a so-called configuration. And these configurations are available from us, again, free of charge, and they combine the detailed settings that you need to comply to the corresponding standard. So if you have to measure according to DIN 15905, then you can download this configuration and you will always be sure that the measurement device, the XL3 will do exactly what it's supposed to do. So you're not risking any misoperation, wrong operation of the device. Okay, let me get back to my presentation and summarize the key points here. Few more words about the measurement series. Typical application when you want to compare levels or spectra. Imagine you are in an open space office. You want to measure the different levels at within the boxes and in the main area. You want to compare them against each other. You want to know the average. So that would be a typical application of such a measurement series. Or another example would be the noise exposure level, where you have to determine the noise dose for the workers here in this workshop over the time. So you are measuring at the typical locations where these people are present over a day, for instance, and then you calculate the result after having acquired all these individual data, for instance, in a measurement series. The measurement series just makes the whole work easier. Summing up what I've showed you, the three displays, the numerical one, the time, the level time graph or level time history, and the spectrum display. We have different frequency, time weightings, readings, correction values or limits, and the measurement series are already presented to you. Talking about data logging and data transfer and analysis, we had a couple of settings we could choose. The log interval, the values, the spectra. You could activate the audio recording. You can create new daily log file if you need, activate gliding LEQ, and the use of the automatic recording of the level statistics, the percentiles. A very important feature of the XL3, a very powerful feature, is its connectivity. You can connect it through your PC via USB, as stated before. You can, by the way, also use a USB to LAN adapter to do that, to have a wired connection to your LAN network, or you can use the Wi-Fi as I am doing here in my presentation. Then we can take a look at what's going on the instrument via this connect.ntiaudio.com website. We can transfer data, we can remote control the interface, and we can use these push service that I showed you as well. Then we have additional features, additional packages and tools that you can download from our myntiaudio.com area, user manuals in different languages, more to come up. We have all these configurations I presented to you according to the different standards, or we have this file validator software. Just want to show you very briefly here on my screen. Here I have logged into this support page of my NTI Audio for the XL3. Here you see you can download the latest firmware. You have the manuals here. You have PC software packages, the file validator that I showed you, and here all these configuration files. Just click on them, download them to your PC, copy them and paste them to your XL3, and they will be active. It's really very simple. And down here we have even more tools like a media player or a formatting software. So all this is available free of charge for the customers of an XL3. That brings me to the end of my presentation. From my side, I want to thank you very much for your interest. I hope I was able to give you a relevant insight in the sound level meter mode of the XL3. And of course, I would be very happy to meet you again at one of our future webinars. For the time being, have a good time, stay healthy. Thank you very much, and bye-bye.